Hello. Process mining is a family of techniques for analyzing business processes, and that is based on event logs extracted from information systems. A large number of business processes are happening between more than one business organization. In such a case, each of the cooperating organizations has its private event log. Organizations are unwilling to, or sometimes illegally prevented from sharing detailed event logs. The cooperating organizations would hire a data analysis firm to analyze this collaborative process, and that is to detect bottlenecks in the process and recommending changes to the process to increase its efficiency. The organization don't trust the data analysis firm or any other third party to the extent that they would share their full event logs with them. Besides, this might not be possible due to privacy regulations. In this demo, we introduce Shareprom, a secure multi-party computation system for inter-organizational process mining. Shareprom allows party A and party B to control what is disclosed to the data analysis firm. In this demo, we assume that party A and B have agreed to reveal time-annotated process map to the data analysis firm, but nothing more. In other words, the data analysis firm will not learn anything about the data either by party A or party B, other than a joint directly follows graph of their processes. Besides, the Shareprom applies differential privacy to the resulted DFG in order to provide an extra layer of privacy. The data analysis firm will neither have access to the specific traces nor any information associated with these traces, and naturally, party A will not have anything about party B, and party B will not learn anything about party A. To realize this scenario, party A and party B import their event logs into their respective Shareprom clients, which are under their control. Shareprom client of each party converts the logs into secret shares. Then it imports the secret shares to the ShareMind servers. Meanwhile, the data analysis firm runs a third ShareMind server. The firm only exchanges secret shares with the servers of party A and B. Then, Shareprom combines the event logs into a single log that represents the joint event log. After that, Shareprom divides the log into chunks for faster processing, and then it performs per chunk parallel sort. Then, Shareprom calculates the DFG matrix. As soon as DFG matrix is ready, Shareprom applies differential privacy, and that is by applying noise to the DFG matrix. After that, only the data analysis firm obtains the results and starts performing the analysis. In this demo, we have this example of two cooperating organizations, a manufacturer and a supplier. The manufacturer is producing goods based on purchase order. Parts of the production pipeline needs intermediate parts from the supplier. The manufacturer orders the intermediate from the supplier. The supplier produces the intermediate, transports the intermediate, and notifies the manufacturer of the arrival. Both parties have their own separate logs. Now, we are going to calculate this inter-organizational process model using Shareprom. To simulate this demo, we are running 3 virtual machines. The first one is to simulate party A or the manufacturer. Second one is to simulate the party B or the supplier, and the third one is to simulate the data analysis firm. First, I'm going to import the data file from the manufacturer. The file has been imported successfully. This is the model for party A or the manufacturer only. I will do the same with party B, the supplier. The file has been imported successfully. And here is the model of party B only. Now, the data analysis firm is ready to run the calculation of DFG. And here is the full result of Shareprom. It has performed a joint DFG calculation of party A and party B event logs. You can notice that there is a change in the order of the activities and the time taken by each activity from the original event logs of party A and B. and that is due to the differential privacy. So, Shareprom enables the data analysis firm to perform the analysis without revealing any individual event from the event logs of party A and B. Also, neither party A nor party B learned anything about each other's private event logs. Thank you very much for your attention.